What if the most mysterious object in our solar system isn't just a comet, but a profound challenge to our understanding of the cosmos? 3E Atlas has defied every established law of cometary physics, its behavior challenging everything we thought we knew about interstellar visitors. Could it be a cosmic puzzle demanding a new scientific paradigm, or is something far more extraordinary at play? Prepare to delve into the scientific frontier, where new discoveries are rewriting the very fabric of astrophysics. For months, the astronomical community has been captivated by a celestial visitor from beyond our solar system, 3E Atlas. Designated C/2023 A3, Sushinshan Atlas, this object is not merely another interstellar comet, it is an enigma, exhibiting characteristics that fundamentally challenge established cometary models. Its journey through our solar system has become a live experiment, pushing the boundaries of our scientific comprehension. Initially, 3E Atlas appeared to be a typical long-period comet, albeit one originating from the vast interstellar medium. However, as scientists meticulously observed its trajectory and morphology, a series of profound anomalies began to emerge. These deviations from expected cometary behavior have transformed 3E Atlas from a mere curiosity into a focal point of intense scientific scrutiny, prompting a re-evaluation of our cosmic assumptions. One of the most striking features is its extraordinary tail, stretching an unfathomable 2.6 million kilometers. This length surpasses the distance between Earth and the Moon, yet its structure remains remarkably narrow and perfectly aligned. This contrasts sharply with the broad, diffuse tails typically observed in comets, which often scatter due to solar-wind interactions and uneven outgassing. Furthermore, 3E Atlas has maintained a consistent, unshakable rotation, exhibiting an unprecedented degree of stability. Comets are typically subject to torques from asymmetric outgassing, leading to noticeable wobbles or even tumbling. Yet, this object appears immune to such perturbations, maintaining its rotational equilibrium with astonishing precision, a phenomenon that defies conventional cometary dynamics. Its outgassing behavior is equally perplexing, steady, powerful, and uninterrupted for over 180 days. Most comets experience significant fluctuations in activity as they approach and recede from the Sun, with outgassing rates directly correlated to solar insolation. 3E Atlas, however, maintains a near constant emission, suggesting an internal mechanism or composition unlike any previously documented. Adding to the mystery are rhythmic cyanogen bursts, observed as distinct, blue, laser-like emissions. These energetic events occur with clockwork regularity, approximately every 16.2 hours. Such precise periodicity in cometary activity is virtually unheard of, hinting at an underlying process that is either exceptionally uniform or perhaps even regulated. This comet doesn't just pass through our solar system, it seems to be communicating, but in a language we are only beginning to decipher. These profound observations have raised far more questions than answers, compelling scientists to confront phenomena that appear to defy the very laws of physics as currently understood. Could 3E Atlas represent a new class of celestial body, or is it merely an extreme outlier within known cometary behavior? The implications are vast, potentially reshaping our understanding of planetary formation and interstellar dynamics. Before we delve deeper into the scientific hypotheses attempting to explain these mysteries, ensure you are subscribed to our channel. Your engagement fuels our exploration, enabling us to bring you more cutting-edge scientific documentaries like this one. Now, consider this thought-provoking question for our scientific community and curious minds. Do you believe 3E Atlas is simply a rare natural phenomenon, pushing the boundaries of cometary science, or could its anomalous behavior suggest something engineered from beyond our current knowledge? A rare natural event, albeit an extreme one. B, a sign of something far more complex, possibly artificial. Share your hypothesis in the comments below. Let's engage in this scientific discourse. As the scientific investigation into 3E Atlas intensifies, a series of remarkable discoveries continues to emerge, each adding layers to its profound mystery. One of the most significant breakthroughs came from astrophotographer Satoru Murata, who captured the most detailed image of the comet to date. Utilizing a 0.2-meter telescope in New Mexico, Murata meticulously combined 24 exposures, revealing an unprecedented view of the object's intricate structure. The resulting image unveiled a chaotic yet mesmerizing spectacle, jets of gas emanating in both sunward and anti-sunward directions. While sunward jets are common, driven by solar heating, anti-solar jets are far rarer and indicate complex internal dynamics or highly volatile materials. This bidirectional outgassing suggests a highly energetic and possibly anisotropic release mechanism within the comet's nucleus, challenging simple sublimation models. The image also revealed a sharply defined anti-tail, a phenomenon rarely observed with such clarity. An anti-tail appears to point towards the Sun, an optical illusion caused by larger dust particles lagging behind the comet in its orbit, viewed edge-on from Earth. The distinctness of 3E Atlas's anti-tail implies a significant population of larger dust grains, or perhaps a unique ejection mechanism that produces them, further differentiating it from typical comets. Beyond its visual morphology, the rotational stability of 3E Atlas remains a central enigma. Scientists have measured an astonishingly low wobble of only 0.1 degrees over a 4-day observation period, despite continuous and vigorous outgassing. In conventional cometary physics, the uneven expulsion of material creates torques that would inevitably induce significant rotational instability, causing the comet to precess or even tumble. This unprecedented stability suggests the presence of an internal damping mechanism or an exceptionally uniform distribution of mass and outgassing vents. Could the nucleus possess an unknown material composition that absorbs these chaotic forces, or an internal structural integrity that maintains its equilibrium? The implications are profound, suggesting either a novel cometary architecture or an entirely different class of object. Each new observation, whether through high-resolution imaging or spectroscopic analysis, adds another layer of intrigue to this already perplexing celestial body. 3E Atlas continues to challenge our fundamental understanding of cometary evolution and the physical processes governing interstellar objects. The data compels scientists to question the very foundations of their models, pushing the boundaries of astronomical inquiry. The profound anomalies exhibited by 3E Atlas have compelled the scientific community to propose several hypotheses, each attempting to reconcile its behavior with known physics, or to venture into uncharted territory. These theories represent the cutting edge of cometary science, grappling with data that defies easy categorization. One leading hypothesis centers on the comet's unique blend of volatile materials within its nucleus. It is postulated that 3E Atlas may contain unusually high concentrations of supervolatiles such as carbon monoxide, CO, or nitrogen, N2. These substances sublimate at extremely low temperatures, far from the Sun, allowing for sustained outgassing even at great heliocentric distances. This could explain the comet's consistent activity over 182 days, defying the typical decline in thrust observed in most comets as they move away from solar heating. Another compelling theory focuses on the comet's internal structure, suggesting it acts as a natural pressure regulator. Scientists hypothesize that the nucleus might possess a complex network of internal conduits, fractures, or a highly porous structure. These features could direct the gas flow in a manner that maintains balance and stability, effectively dampening any rotational torques. Such an internal architecture could explain the remarkable absence of wobble, as outgassing forces are absorbed or symmetrically distributed, preventing chaotic rotation. A more speculative, yet scientifically considered, hypothesis posits that 3E Atlas might be an object of non-natural origin. Given the extreme precision of its rotation, the rhythmic cyanogen bursts, and the sustained, regulated outgassing, some researchers entertain the possibility of an engineered structure. While extraordinary claims require extraordinary evidence, the scientific method demands that all possibilities, however remote, be considered when natural explanations prove insufficient. This hypothesis, though controversial, underscores the extent to which 3E Atlas challenges our conventional understanding. These hypotheses are not mutually exclusive and may even combine to explain the comet's multifaceted behavior. The ongoing scientific endeavor involves designing experiments and observations to test each theory, systematically ruling out possibilities until the most robust explanation emerges. This rigorous process is fundamental to scientific discovery, pushing the boundaries of what we know about the universe. As 3E Atlas continues its trajectory, approaching its perihelion and closest point to Earth in December 2025, the global scientific community is mobilizing for an unprecedented observational campaign. Observatories worldwide, both ground-based and space-borne, are preparing for high-resolution imaging, spectroscopic analysis, and astrometric measurements. This pivotal period is anticipated to yield a wealth of data, potentially providing definitive answers to the mysteries that have accumulated over months of observation. One of the primary objectives is to precisely measure the velocity of the gas and dust ejected from the comet. If the cyanogen bursts continue to exhibit speeds in the range of hundreds of meters per second, it would lend strong support to natural explanations involving volatile sublimation and gas expansion. However, if these bursts are found to reach velocities of kilometers per second, it would suggest a far more energetic process, potentially indicative of non-thermal mechanisms or even artificial propulsion. Pushing the boundaries of conventional cometary physics, researchers will also meticulously monitor the evolution of 3E Atlas's tail and anti-tail structures. Changes in their morphology, composition, and dust distribution as the comet interacts more intensely with the solar wind and radiation will provide critical insights into its material properties and outgassing dynamics. The formation of new jets, the consistency of existing emissions, and any variations in the comet's overall activity will be rigorously documented and analyzed. A key focus will remain on the comet's rotational stability. Scientists are eager to track whether its minimal wobble persists as it experiences increased solar heating and gravitational stresses. Any deviation from its current steady rotation could provide clues about internal structural changes or external influences. Conversely, continued stability would further strengthen the case for an intrinsic, perhaps engineered, damping mechanism. These upcoming observations are not merely about understanding a single comet, they represent a potential paradigm shift in our comprehension of interstellar objects and cometary science. The data gathered from 3E Atlas could necessitate a complete revision of existing models, opening new avenues of research into the formation, evolution, and behavior of celestial bodies originating from beyond our solar system. The questions raised by this enigmatic object may very well lead to answers that fundamentally reshape our understanding of the cosmos. As 3E Atlas continues its extraordinary journey through our solar system, it stands as a profound challenge to everything we thought we knew about comets and interstellar objects. It is only the third such confirmed visitor, following Oumuamua and 2I/Borisov, each of which offered tantalizing glimpses into the diversity of extrasolar bodies. However, 3E Atlas distinguishes itself through its bewildering array of unprecedented anomalies, compelling the scientific community to fundamentally reconsider its foundational assumptions. The consistent, stable rotation, the sustained and regulated outgassing, and the rhythmic cyanogen bursts collectively suggest that our previous models for interstellar object behavior are woefully incomplete. 3E Atlas is not merely an outlier, it is actively rewriting the rules of cometary physics. Its defiance of expected thrust decay and rotational instability forces scientists to explore novel mechanisms, whether they involve exotic material compositions, complex internal structures, or even more speculative, non-natural origins. This comet is not simply a rare natural occurrence, it is an enigma that demands deeper exploration into the very nature of the cosmos. Could 3E Atlas be a window into a broader cosmic mystery, revealing processes or phenomena previously unimagined? Or could its highly ordered behavior even be evidence of something far more complex, perhaps even engineered, by forces beyond our current comprehension? The scientific pursuit demands that we rigorously investigate all possibilities, however unconventional. The ongoing study of 3E Atlas transcends the unraveling of one object's secrets. It is about pushing the very boundaries of human knowledge. Each new observation, every meticulously analyzed data point, brings us closer to understanding not only this remarkable comet but also the vast, intricate universe itself. 3E Atlas serves as a powerful reminder that there is still an immense amount we have yet to learn, and with every revelation, we inch closer to the profound answers hidden within the stars. As we gaze upon 3E Atlas, we are reminded of the boundless unknowns that permeate the vastness of the universe. This comet, with its baffling anomalies and remarkable behavior, challenges our most fundamental scientific understanding and forces us to question established paradigms. Its unprecedented stability, precise rotation, and rhythmic emissions suggest a level of order that transcends typical celestial mechanics. Just as 3E Atlas has defied all expectations, we, too, must embrace the unknown and push beyond the limits of what we believe is possible. The profound lesson here is that intellectual curiosity and scientific perseverance are the indispensable driving forces behind all discovery. By rigorously questioning the ordinary and relentlessly seeking to understand the extraordinary, we unlock new realms of scientific possibility. Much like the dedicated scientists meticulously studying this enigmatic object, we must not shy away from the mysteries of the cosmos, but instead dive deeper into them with open minds and a commitment to empirical inquiry. As we continue to explore the unknown, let us remember that every scientific answer invariably leads to even greater, more profound questions. 3E Atlas reminds us that the pursuit of knowledge is an endless, exhilarating journey, a journey filled with wonder, groundbreaking discovery, and intellectual growth that truly enriches our collective human experience. If you've been captivated by this scientific exploration of the cosmos and wish to continue learning more about the profound mysteries of our universe, don't hesitate to subscribe to our channel. Your support and engagement inspire us to keep sharing cutting-edge content that will leave you thinking long after the video concludes. Join our community of cosmic explorers.